For our last week, I wanted to record a quick little video to show you guys how to calculate the correlation coefficient, coefficient of determination, slope, and intercept for bivariate data using Excel. Now, the textbook shows you how to do this using a handheld TI calculator, but there is no need to buy a calculator when all you guys have access to Excel and it will do these same functions. So the first thing I'm going to do over here is copy my data and then paste these data into Excel. Let's start with the correlation coefficient. And our abbreviation for the correlation coefficient is R. So in Excel, I'm going to hit the equal sign, then correl, the first 6 letters of correlation, open the parentheses. And for correlation, it doesn't matter which you put first and which you put second, whether you put your x's first or your y's first. I'm going to highlight my y's in this case, bone density, put a comma, and then highlight my x's, which is age, and close the parentheses. For the coefficient of determination, the coefficient of determination is r squared. We can just take the value we just found for r, so I'm going to hit an equal sign to enter a formula, select r, and then square it with the caret 2. For slope, which we use the notation beta 1 or b1, the command is equal slope, open the parentheses. Now this one is important that you put your y's first. Correlation coefficient, the order didn't matter, but order is important here. So I'm going to select my y's, which are bone density, comma, select my x's, and close the parentheses. So for my y-intercept, which our notation here is beta naught or b naught, I'm going to hit the equal sign to enter a formula, intercept, open the parentheses, and again, order is important here. I'm going to select my y's first, comma, and then my x's. So that will give you the correlation coefficient, coefficient of determination, slope, and y-intercept. Now there's one other way to get all this information at once. If I select my data and I insert a scatter plot. Okay, so I see my scatter plot here, and you're probably not surprised that that correlation coefficient and slope are negative because we have a decreasing trend. I'm going to go here to the plus, and I want to add a trend line. We want this trend line to be linear. Now when I go down to more options, we want to display the equation and display r squared. So when we do this, do you see that? Let's see if I can move this up here. We are also here given our slope, our y-intercept, coefficient of determination. Now, if you use this second strategy I just showed you, do you see I do not have the correlation coefficient? So if you wanted to work backwards, you could find the square root of r. Now the tough part is it's always going to give you a positive answer. So you would have to know here that if the slope is negative, well then the correlation coefficient is also negative. So if I wanted to use that strategy, I would hit the equal sign. I know that this is negative because I have a negative slope, and then I want the square root, SQRT, open parentheses, of this r squared value that was given me down here in my chart, which is 0.9008. And we get pretty much the same value. So you have two strategies there for correlation and regression. You can do each command separately with correl, then square that number to get r squared, slope, and intercept, as I showed you at the beginning. Or you can insert a scatter plot, and then once you insert your scatter plot, we go to the plus sign over here, trend lines, more options, and then make sure you display the equation and display r squared. Let's assume that my version is asking me to predict the bone density for a 45-year-old. So we want to do an estimate here when x is 45. So I have my regression equation, and what I want to do is plug in the value of 45 for x. So I'm going to hit equal. My slope here is negative 1.7457. So I'm going to select that cell, times, okay, the value of my x is 45. And then I'm going to add to that the y-intercept here, which is 422.524. And then I hit enter. You could do all this with the rounded values given here in the scatter plot. If I hit equals negative 1.7457, I'm going to use the asterisk for multiplication, 45, plus, and then this rounded value I see in my scatter plot is 422.52. And to two decimal places, these are more or less the same, whether you use the rounded model down here or whether you use the exact values that we calculated earlier.